Hey everyone, here's another example from section 2.2. This is an example where we're going to have to use the squeeze theorem. So there was a video on the squeeze theorem that was one of your kind of conceptual videos that you were supposed to watch. Basically they have this inequality and they say if square root of 10 minus 7x squared is less than or equal to f of x, and then f of x is less than or equal to square root of 10 minus x squared, for negative 1 less than or equal to x less than or equal to 1, they want you to find the limit as x approaches 0 for the function that's in the middle. So this is where the squeeze theorem comes into play. F of x is bigger than this function, but it's less than this function. So if we find the limit as x approaches 0 for this function, and we find the limit as x approaches 0 for this function, we know f of x's limit as it approaches 0 is going to be between those two things. That's kind of the squeeze. That's the idea behind the squeeze theorem. So the first thing I'm going to do to start this is I'll write down, we're going to use the squeeze theorem. Hopefully I spelled squeeze right. Maybe. If I didn't, forgive me. So we're going to use the squeeze theorem. And what I'm going to do is I'm going to find the limit as x approaches 0 for the first part, which is the square root 10 minus 7x squared. And that's going to give square root of 10 minus 7, 0 squared, which is going to give, that will be 0 times negative 7, so that ends up just being square root of 10. So this first part has a limit, so as the limit as x approaches 0 is square root of 10. Alright, then I'm going to look at the other part. So I'm going to say limit as x approaches 0 for square root of 10 minus x squared. So I'm looking at this right side now, and I'm going to find the limit as x approaches 0. That's going to be square root of 10 minus 0 squared, which again gives me square root of 10. You guys should be able to see where this is starting to go. So if I look at this whole thing and I say limit as x approaches 0, square root of 10 minus 7x squared is less than or equal to, we know this is true, so this limit has got to be less than or equal to this limit as x approaches 0 for f of x, which then should be less than or equal to this limit as x approaches 0 for square root of 10 minus x squared. And now the squeeze theorem comes into play. I already found this limit. I found this limit right there. This limit here is actually the square root of 10. This limit, I just found that right there. That is also the square root of 10. So that means the square root of 10 is less than or equal to limit as x approaches 0, f of x, which is less than or equal to the square root of 10. So the limit as x approaches 0 of f of x is between square root of 10 and square root of 10. Well, that's the same number. So that implies that the limit as x approaches 0 of f of x is just equal to the square root of 10. And that's our answer. That's the squeeze theorem. Hopefully it makes some sense.